This video is to give you a closer look at this tensegrity structure and the different parts of it. So if you can see, it's made from two styrofoam cups. And the reason to use styrofoam cups is mainly because the styrofoam cups are identical. And so it was easy to cut two symmetrical sides of this structure from the cups. Looking more closely at these separate structures, looking at the bottom one, you can see that I left a ring from the top of the cup upside down, and then I created an upright part that used the bottom of the cup to have an overhang, and the top part is exactly the same as the bottom part. They're cut the same way in order that I could have a point from the bottom part that overhangs directly over the top part, so that the top part could hang from the string that connects these two structures. This is a tensegrity structure, so it's held together by tension only. The main tension that's holding up the top part of the cup is that center thread. I chose to use black thread so that it would be somewhat visible, I guess, to make this structure. Aside from that center thread, which is obviously very short, there are several threads, 3, that connect the sides of the top cup to the bottom cup. The primary function of those threads is to prevent this the top cup from tipping over. As long as it stays upright, it will hang from this middle thread, and it will remain a stable structure. You can see it's wobbly. You can poke it. But because these threads are keeping it from toppling over, it's stable. It's actually not unstable if it's moved. So I can turn it, and now it's no longer hanging, but the tension actually will transfer between the different threads, which is a nice feature of having these threads be symmetrical. So they're radially symmetrical. Each are an equal arc angle around the circle. That's part of what keeps them from tipping over. Technically, the fact that the weight is more shifted to this side than this side means that there is a downward force on this side that unbalances this. So you could actually do this without 3 threads. I chose to use 3 threads because it makes the structure more stable, and it allows you to do things like turn this thing upside down and have it remain stable. You can disrupt the stability by toppling over the top if you do it forcefully, and then you can also replace it. I'll show you that. You can break the structure by doing this, and then the structure is actually easy to replace by doing this. So if you're going to recreate a structure like this, I'm going to recommend that you look carefully at this video to see the details of this cup, or this 2-cup configuration. And a couple of recommendations that might make this easier for you is that I made loops in the thread. So these threads, if you look, I poked through with a sewing needle, and then I fed thread through those holes, and I made loops. The reason that when I tied the thread together, I tied it in a loop rather than tying it tight, because the loop can be moved. The little piece of thread that sticks out, this allowed me to adjust the length of these threads by pulling on by adjusting this loop, kind of like spinning it like this one way or another. It changed the tension in this thread. Same thing for the other threads. And then when the tension was right, I actually put a little dab of glue in place on the threads to keep them from slipping. But if you make loops, you'll be able to readjust the tension of the threads. That might help you get the tension right, because what happens is if these if these threads are tensioned differently, the thing will like tip like this. It may still work, but it might be easier if you create loops that you can kind of turn. The loops aren't super important, but they might help you. You may find other ways to make this easier. You may find using 4 threads works better or something like that. In any case, if you have any questions about building this, or if you attempt to build a structure like this and you run into some trouble and you want to describe the problems you're running into and how you tried to solve them, I'm sure that would be very interesting.